Bom dia a todos. Eu, infelizmente, não vou falar brasileiro, porque senão a gente vai achar que está numa telenovela. Infelizmente, não vai ter cena do beijo. Vamos falar de Java aqui hoje. And, well, my name is Julio. I work at Amazon, and I'm here today to share some architectural advice and things I see a lot in customers. And we got only 1 hour today, but if you'd like to keep in touch, I'm Julio AWS on Twitter, and I would love to continue this conversation. And it is all about building well-architected backends for modern Java applications. So the whole idea is to answer a very simple question. How do you demonstrate your architecture is ready? How you show yourself and others that the thing that you built is ready to run? And the answer to this varies a lot. If you ask and try to answer this, I had these discussions with many customers, it very frequently starts like this, like we are using this stack, like this big company that inspired us, so we should be fine. If you're into an enterprise environment, you may see something like we're in an audit, so we are standardized on a specific compliance standard, and we are good to go. But is this enough? We can go a bit further and try to demonstrate that the application is ready using automated tests. And this is where most of the projects I work stop. Like, test what you can and hope for the best, right? That's the way I see a lot of people doing. And it is very important to do testing, and every sort of automated testing is valid, but the thing to think about is that enough? Is that sufficient to prove that my application is ready and done? Because very commonly, if you don't think about this, you're going to see a lot of people doing so much cool stuff on the cloud with microservices and all the great things that we've heard about today, but am I missing out on this stuff, or should I keep my old architecture and do things as I'm doing now? And I believe the only way to answer this question is to change a bit your architecture mindset and start moving from the right side to the left side, from the black to the blue, instead of doing optimizing and trying to go for the best and be qualitative. You should be trying to satisfy requirements in a more objective manner. What do I want to say with this? So optimizing means that I see a lot of people just trying to get the best throughput, the best latency, the best performance. And it is important, but it's much easier for business if you set goals that you can validate, that you can satisfy or not. So if your latency percentiles are at a given threshold, or if your throughput threshold is in this limit, this makes it much easier to assess and to comply. And it is very important that you are objective when you're doing this. Like, have you seen this 100% secure? Like, what does it even mean can you answer, like, is it secure or not secure? Does it even make sense? We have to break it down into privacy, encryption, and everything that involves security nowadays. And by the way, everything that you see on these slides and every example is a feature of the platform, and we can dive deeper on this if you'd like. And be quantitative. Not always it's possible to be quantitative. If you can say that you need a monthly uptime that's 3 nines or 4 nines or 5 nines, it really helps. So try to be quantitative when you can, but sometimes it's a bit hard. So everything that's architectural and these decisions are not so black and white, so take it with a grain of salt. And another very important thing is to make them durable and not ephemeral. What I mean by this? Well, say that you want to add markup language to your project. A lot of people just add a dependency to the POM file or to your project management and code and keep on coding. But just doing this is a crime against the future generations that are inheriting your project, because, or even to yourself in the future, you may say, well, why did I do this? Why did this happen? Why did you choose this library and not the others? And all those questions that may come up in the future, and perhaps you will not even be there to answer, so make them durable. This is example format called architectural decision records to add the things. So I chose this library because of this, because of that, in this context, and it had this effect. And if you can, share that with other people, making this information shared and added to your repo, and making your architectural decisions part of your source code can really improve the communication, not only within your team, but also to the software community in general. So when you go to your meetup and talk about your project, people can go there and see why did you choose the things you chose. And at Amazon, the way we do this is something called the AWS Well Architected Framework. Those are the set of requirements that we assess. So when we are demonstrating architectures, we look at security, reliability, performance efficiency, cost optimization, and operational excellence. And the most important part of the well-architected framework are the questions. So for example, in security, we have questions like, how are you protecting access and use of the root account credentials? When we talk reliability, how are you testing your resiliency? We're going to talk a bit more about that soon enough. If we're talking performance, how did you select your compute solutions? And if you're talking operations, like how do you make sure your capacity matches but not exceeds what you need in cost, so you're not wasting money? And on operations, how do you know that you're ready? Right? What are your questions? Because the important thing about the well-architected framework is not the framework itself, it's the method. You should add your own questions. Those are great questions to start with, but some of them may not make sense for you. You may add or remove. After all, it's your project. So let's talk a bit about each of those areas. Security is our job zero, and I'm sorry to tell you that the security talk is in the other room, but it's really important. Hear what Simon has to say. His talk is great. I just saw it at JBCN. And the things that I'd like to make clear and remind everyone is that security is not the hacker duel that we see in the movies. Security is an automation thing. There is no such thing as, oh God, we're being hacked, what we're going to do. Usually you're going to find out much after. For example, the Equifax case in the US, probably the largest data breach that we have in years, it took them 2 months to even find out that they were hacked. And this is easy to see, like how do you detect these things? And at the scale that we are today, this is WannaCrypt. Last year, WannaCrypt devastated the internet in 4 days. So there's no time to think, to take a measure. You have to anticipate and prepare your architectural security. And it's important to see, especially with all the things that are going on with GDPR, that identity management and encryption is not the same thing as privacy. Like, how do you protect your applications and data, even from the people that work within your company, right? Think the case that is much interesting to me is this Snowden, of course. This, how do you avoid the Snowden in your company, right? How do you guarantee to users that their data is private and safe, and even if the CEO wants to sell the company, you can prove that data is safe? And this has to do with encryption, with key management, and a lot of things. For example, it's very common nowadays that you don't even have identities in production environment. So if everything is automated, if you have your DevOps right, you don't need to log into production machines. Like it's commit, and the automation process should get things through the door, right? And this kind of measures make it much easier to protect your environment. But by more protective that you are, you can always have problems, and you need to find a way to detect it. And today, the most efficient and used way to detect intrusion and other problems in your infrastructure is log analytics. And log analytics is something not to be done in the end of the month or in the end of the day. You can do it live. And doing log analytics live allows you to see things that you wouldn't see otherwise. And it's important because sometimes you don't even have servers anymore to monitor or detect. With all the serverless team, you can think like, well, what is left to protect? If I don't have servers, the hackers are going to hack what exactly? And you have to think that your application needs to be patched. You have to think about the DOS resiliency and protecting from all sorts of attacks that are against your app, against your data, such as the Equifax case. This is the whole idea. And we are seeing a lot of machine learning going on in this space. For example, you have to learn the access patterns. For example, say that you have one call center operator looking the address of a person. It's completely normal. It's a customer representative looking at one customer data, it's okay. If he's looking at two customer address, it's okay. But if he's fetching all the customer addresses in your database, perhaps there is something wrong there. So it should be investigated. And the only way to do this is through predictive analytics. You put the logs. So again, it's an evolution of the live log analytics. After doing live log analytics, perhaps you want to do predictive log analytics. And the machine learning tools that we have today allows for a lot of that. And more importantly, have a tested and well-done plan. Like if you get hacked, if you get a security issue, how you're going to automate and stop serving data so you don't leak even more data, how you're going to communicate to the stakeholders what is happening and what is not, and again, how you're not taking 2 months to discover that you got hacked. So this is the kind of security things that you need to think about. And again, at AWS, we have some answers for a lot of this, and take a look at the Well Architected Framework for more information on that. So let's move to reliability. And this is where the whole microservices team come in. Because at Amazon, the way it happened was in 2001, Jeff Bezos came down from the mountain and said, everybody is going to work in 2 pizza teams. And American pizzas can feed a lot of people, but it's going to be like 10 to 15 people at most in a team within Amazon. And this is totally true. So the whole microservices thing is not easy to do. Like, imagine that the whole Amazon.com website was a single library. It was a single file, a Perl library, as far as I can recall. And breaking this into microservices is not easy. You have to strangle the monolith, adding a router, so that when you introduce your own component inside, in the middle of the communication, you can split a part of the requests to the new system and test everything, and then you can slowly go into this microservices architecture. And this router can be many things. It can be DNS, a CDN, a load balancer, a Zoho instance, and whatever you guys would like, ECIO and things like this. And after 7 years, in 2008, Amazon infrastructure already looked like this Death Star of microservices that we usually have. And deploying this and maintaining this is not easy. So infrastructure as code became invaluable. So the whole idea of infrastructure as code is not just to automate and deploy when you push, but to be able to divide your company and grow as a business, and not only to satisfy or move to this microservices architecture. Perhaps the monolith is more adequate to your business. It's more on the organization, on the business side, than on the technical part of things. If you'd like to know more and talk more about infrastructure as code, I'm also the author of the infrastructure as code white paper that's on the Amazon website, one of the authors, and I'd love to continue this conversation there. But the thing that it allows is the automation in an unprecedented level. You can provision and change components at runtime at a scale that would be impossible in other ways. For example, at Netflix, they have this project called the Simian Army, where they started with the Chaos Monkey. The Chaos Monkey randomly selects a server in your account, in your AWS account, and terminates that one. And just to prove that losing a server wouldn't be so bad. And they moved on to killing entire data centers and entire regions automatically. So in this example, when they get their API errors up, they start moving traffic to other regions. They run in 3 regions in the US, and they can automatically shift traffic and evacuate a whole region within 7 minutes or so. So think at the scale that their operation is. This literally means at peak scale, about 40% of the whole US internet traffic is just Netflix. And it's one of the customers. It's estimated that up to 70% of the internet traffic goes through US East 1. And they can fail over and fail back at this gigantic proportion thanks to this infrastructure as code. And it's all tested and secure. And for you, you don't see a glitch. You can continue watching House of Cards as if nothing happened because of Chaos Monkey is continuously testing that this is true. And I'd like to talk a bit about performance, because we're talking about selecting compute options here, and you guys have a lot of compute options nowadays and a lot of things that you can do. And the world has changed in performance. What used to be considered big data today fits in RAM, right? So, for example, at AWS, we have these instances with, this is 4 terabytes of memory in one machine. So, if you have this out-of-memory exception that you're having a problem, or if you really like tuning your garbage collection, 4 terabytes of RAM can be quite a thing. Or 128 CPUs. And this kind of thing is becoming common and common nowadays. And we can do this for CPU, for memory, for disks. This is like 200,000 IOPS in a wide array, in a single server. So the things that we consider nowadays as big is very different than it was just a couple of years ago. So make sure you review and test your application with the capacity that it's adequate and with the modern cloud resources that we have. For example, if you're doing machine learning, we have these GPUs, and Netflix and many other customers use this for machine learning, for training neural networks and things like this. The Tesla Volta is a project from NVIDIA, and it's literally at the limit of photolithography. Like, you can't compress physically more components than they have in this chip. And the performance numbers are just absurd. They can do 15.7 petaflops in 32 blitz operations. Like the whole idea of this GPU and the most powerful thing is this tensor cores. So let me explain. The whole thing about tensor cores is doing a very simple operation. A times B plus C. So matrix multiplication and accumulation. But it can do up to 125 teras of those operations per second. So it's a really, really powerful GPU. And in a single instance, you can have 8 of those, communicating at 900 gigs per second between one another. So you can see the kind of neural, and this is behind the advances that we see in machine learning and image recognition and so on and so forth. But the GPU is already done. You can't, it has its instruction set, its data paths, it's everything already built, and you can't do very much about it. But there is another kind of acceleration, the FPGAs, the field programmable gate arrays, that can give you your own custom acceleration. You literally write circuits. The hardware changes to your needs. You compile to hardware. So those instances have this field programmable gate arrays. You can compile your elliptic curve or your algorithm, that part of your code that's 80% of the time, and things like this. Rift did it for Elasticsearch, and they got absurd performance benefits from that. But what sense does it mean to be talking about CPU, memory, GPUs, and FPGAs in these days where everybody is talking about serverless, and the servers still matters? So we do have that, and serverless is truly important, and for many applications, that's true. For some applications, FPGAs are crucial. For others, you don't even care about the server. You just want to say, hey, I've got a function, I got to bind it to an API, I bind it to logs, debugger, and run, please, AWS, do this for me, I don't care, right? And it will run according to your specification and be invoked in reaction to the events that you specify. And this is the code behind it. It's a regular Java code. It can take Java types, your custom types, and string types, and be as coupled as you want. But it's just a method call in the end. If you'd like to reuse components, for example, you're talking a lot today about microprofile and Java containers and things like this. We have this AWS Serverless Java Container project on GitHub AWS Labs. That's the bridge between the serverless world and the Java application server world. You can connect them and run Jersey, Spark, Spring, or all your favorite Java libraries within the serverless ecosystem using this bridge. And when you do this, you have to be very mindful, because you can, but it's not the same thing. For example, in traditional Java applications, we spin up a whole pool of resources, connection pool, thread pool, and all the pools that you want to keep warm. But in the serverless world, where servers go up and down in a matter of milliseconds, does it make sense to heat up 50 database connections? Probably not. You have to understand how the containers are reused, because those functions run in containers, and these containers are reused from one execution to another to save performance. So in the end, it's all containers anyway. And we need to think about this, because containers are also a great way and a great compute option that you have. So the important thing I think about containers is, what do you containerize? Like, you have this whole ecosystem of deployment solutions, NoSQL database, a lot of components that could be into containers and that are already available as containers, but let's think of a relational database. MySQL, for example. If you try to containerize a MySQL, you have to define your primary rights, your primary instance, your failover instance for high availability, your read replicas for performance, making sure that they're not on the same host, because if one host fails, you don't want everything down, and so on and so forth. Meanwhile, we have a service at Amazon called Aurora that automatically, just by spinning a database instance, spins 6 replicas in each region, 2 per region, 2 per availability zone. And it's, on average, 5 times more performant than the regular MySQL, with lots of authentication, encryption. You can do even serverless procedures. So you can do call a procedure on your MySQL instance, and it can trigger your serverless function the same way you could do over HTTP and things like that. And moreover, we have this serverless now. So serverless databases is a thing. So think about it. Is it worthy to recreate all this infrastructure yourself and try to containerize the world, or just reuse this kind of service? And that's a pretty important architectural decision. And again, it's hard to say what is business logic and what is not, right? Well, everybody draws the line a bit differently. But if you do choose containers, we have the service called the Elastic Container Service. That's one option to run the containers for you. You define your cluster, your container instances, volumes, and everything that you'd like to run on containers, and simply say how much memory they take, how much CPU they take, and they will be distributed by ECS. You can tell ECS to reload those containers and manage everything for you, and even control the deployments. For example, you can say that you want to have a minimum of 50% health instances, so when it deploys, it will deploy to half the servers first, and then to the other half. Or if you want, you can deploy to a whole new fleet of servers and do totally blue-green deployments. And this is managed automatically by the service. And all with the proper monitoring and scaling that you would expect. So this is one way to run things, but there are others. You can choose to not define the architecture yourself, not to worry about the underlying instances. If you choose to do this, we have a thing called Fargate. And the whole idea of Fargate is you don't worry about the underlying platform. You don't have to spin up an instance to run a container. You just say to AWS, hey, your container, I want a container with this much CPU, this much memory, and you pay by what you use without even knowing what is underlying, and you don't even have to care, right? The only thing is, this is ECS. This is Amazon way of managing things. And for many customers, it is important to be independent and to run on premises, to run on other clouds. So a lot of people is doing this on Kubernetes. And Elastic's container service supports Kubernetes as well. So if you want to run your Kubernetes workload, the same Kubernetes that you have upstream on GitHub, but at production scale with service integrations, with auto-scaling and things like this, we do have this option. It's called EKS, and it will manage Kubernetes master. It will be a highly available Kubernetes cluster as a service. And the whole idea here is, how do you want your compute to be done, right? Do you want it to be done on this standard fashion, but you have to understand Kubernetes, or I don't care about Kubernetes, just run things on Fargate and pay for what you use? That's the whole decision that have to go. Also, we have a container registry that's totally tied to this. But again, does this matter to you? Does this matter to your customer? Does anybody care what a container actually is? So if you don't, we have another platform called Elastic Beanstalk. On Elastic Beanstalk, it's send your package. It can be a jar package. It can be a war to be run on Tomcat. It can be a Docker container. You can just say the image, and it will take care of everything for you. So you can swap URLs. You have health monitoring checks, software configurations, instance, auto-scaling, all that you would need to deploy and run apps without having to manage everything. So the whole perspective that I'd like to share is that you can choose. You can select the compute option that is right. It's not servers versus serverless versus containers. You can use serverless for the things that you don't care where it runs. You can use containers for the things that you want to be portable, exchangeable, and things like this. And you can care about the servers and the underlying resources and the hardware acceleration and things like this when it matters. So the well-architected app may be a composition of all these things and not trying to understand if one is better than the other because they are not really alternatives. And the thing that usually worries people when we talk about this is, does it bind you? If I choose to use a server, so for example, we were talking about Aurora. If we use Aurora instead of MySQL, does it bind you to Amazon? Does it create a vendor lock-in, or is it something that you can roll back? So the whole idea is that you can use open standard and standard protocols. For example, the MySQL Aurora database speaks the same MySQL protocol than any other MySQL. So if you'd like to roll back and run on other cloud, on other data centers, on your place, you can just do it when it's needed. You don't need to reinvent the wheel just to prevent the vendor locking. So using open standards, open source, these standard protocols, or even a custom driver to bridge and make the calls to the service that you need may easily get you out of this situation. And the whole idea is that you don't need to understand all the details and be a great system administrator to run your app, but you need to understand these things. What do you want? You want a server, a container, or a function? Because each may have a different place in your architecture. And some tips for cost optimizations. If you check, if you're not running with a content delivery network with HTTP caches, this can really save a lot of money. If you just consider traffic, it's probably the hugest part in many customers' bills. And if you cache your resources, this is a real case from a customer that if you see the total bytes that were transferred to viewers, it's 100 terabytes per month, more or less. But if you see the total bytes from misses, it's just 5%. So only 5% of the requests actually made it to the backend. Most of the resources didn't even get to the request didn't even get to the backend. And every cloud provider will have different pricing models that can save a lot of money. For example, this P3 instance is the instance with 8 GPUs, the most powerful NVIDIAs that I was talking about. 8 of those is in a single machine. This costs $24 per hour on demand. But if you go to a reserved instances that you can pay in advance and get a discount, you can go to 15 or even 9 per hour. And if you go to the spot market where the price fluctuates a bit, you can get down to $6 or $7, between $7 and $8 per instance. So if you understand and make it more flexible, you can truly save a lot of money. This is Lynn Langit. She has a really good presentation on serverless, where she shows that a project that took $9 million for the Australian government to build and failed on the first day. It was the census project. And on the first day, it completely crashed. And 2 students at a hackathon built the same thing. They scraped the web pages, the HTML, and built the exact same thing for $500. Because on serverless, you pay only per the milliseconds you use, per 100 milliseconds, and this can save a tremendous amount of money. And on the operational excellence side of things, my best advice is take a look at the ThoughtWorks Technology Radar. They have a lot of good tips and techniques and tools that you can use. And more importantly, just like the well-architected framework, the important thing is not their radar, it's the method. Build our own radar. How you decide on the technology on your company and adopt these things through a method and not through guessing. And for example, the architecture decision records that we were talking about, it's discussed there. And all these things that we were talking about, like blue-green deployments or canary testing, and most of the things we saw today are there, so take a look at that. And in the end, the idea is cloud, the first age of the cloud, and the most interesting thing about the cloud for me is that it is very democratizing. It gives you access to those resources. It gives you containers, it gives you servers, FPGAs, GPUs, terabytes of RAM. But what about the knowledge? What about the how-to? What are the architectural decisions that are successful? This is not so easy to democratize. So that's why I insist that architectural definitions should be satisfying, not trying to optimize everything, but reach specific and objective criteria, if possible, established in the best numbers and as clear and objectively as possible, making it durable in your shared repository, make those, commit those with your code, and share that so we can help everyone to be well architected. And that's it. Muito obrigado, gente. Any questions? I'm up. Yep.
Can you further elaborate on how security is related to automation?
Yeah, think, for example, the Equifax case. They ran a compromised version. The struts bug was struts had in an exception handling of struts 2, they could execute malicious code injected into HTTP headers. It was out 4 months before the CVE was documented and solved 4 months before. They could, we have at AWS and from other providers tools that automatically check your POM file, your package JSON, all your dependencies to see if there is a CVE, published vulnerability for that specific version. And you add that to your continuous delivery pipeline. So before you release code, check if the dependency is vulnerable. And after it's deployed, you can do all sorts of static analysis. There is like code analysis as well. But it's not only code analysis. In runtime, the same type of agent can verify memory consumption and access patterns and traffic patterns to check if the machine and if the operating system is compromised or not, if it's integral or not. And after it's running, and even after outside of the servers, the log analytics can continuously monitor and try to find, even predictively with machine learning, this kind of attacks. So it's not one specific thing, but you go automating each part of your continuous delivery pipeline to give you the signals that you have a security issue.
Hi, you mentioned Amazon Aurora. I believe both the multi-master and the serverless capabilities are on preview. Do you know when they will be production ready?
Unfortunately, I can't share this. I can't share the dates, but very soon, I hope. If you're interested in the preview, or if you're interested in anything at all that I said, please send me a direct message on Twitter, and I can share you some AWS credits and help you play with every one of those services.
Thanks.
All right. Thank you so much.